So before I started up a Ubuntu image, created some files and directories, and then exited the container, went back into it again, started it up again, and we saw that those files were gone. Yeah. So let's have a look at the scenario where we don't want that to occur. When we start up our application, we want our files, directories, structure, configuration details all already created in the image. How do we do that? How do we create an image for our application, for example? Yeah. So how we do that is based off the easiest way. There's a couple of ways you can do it, but the easiest way is based off a thing called a Docker file. And a Docker file basically goes through and specifies the base image that your image is going to be based off, and then what changes you want to make to that base image to make it into to have what you want in your image in it. Yeah. So let's create a directory here. I'm in my Docker directory, so let's make a subdirectory called example1. Okay. And then actually I've got an editor open, so let me jump over here. Inside my editor, let's create a new file, which is going to be called, let me save it. Let's save it in here, and we'll give it the name of Docker file. Yeah, it doesn't have to be called that, but by default you call it that. It's kind of a convention. Yeah. So here's my Docker file. So as I said before, I want to do two things in here. I want to specify what base image my image is going to be going to inherit from a particular image. So for that we use the from statement. So I'm saying from Ubuntu, and in my case I don't want to just say latest or leave it up to the default. I want to specify that my image is going to be based off Ubuntu 16.04. Okay. The other thing that I said you do in a Docker file, I said that you specify what image you're basing your custom image off. The second thing that you do is specify whatever commands that you want to have executed as part of creating that image. Yeah. So we do that using the run command. Yeah. So I can say run, and then whatever commands I want to set up the image the way that I want it set up. Okay. So in my case, I went through, I ran cd to my home directory. Okay. And then I said run, or then I said make the test, I think I did. Can't even remember what I did now. And then I said echo hello test into a foo file. Okay. So in theory, you can go through and just stick a whole bunch of run commands in here. You can install packages. You can depending on your flavor of Linux, you can pull down other packages to be installed. You can do really whatever you like. You can open up ports, all that kind of stuff. But it basically what happens is for every one of these run commands, it will create a new image. Yeah. So here I'm going to start with my Ubuntu 16.04 image. It will then create an image inheriting from that, if you like, or based on that, that contains the changes after we've done the cd home or tilde character. Yeah. And then it will create another image off that one which has that in it plus the results of doing a make the test. Yeah. Then it will create another image based off that with the changes of echo hello test, into foo. Yeah. So you end up with all of these interim images, yeah, which can be fine, but it's a bit slow and it's a bit, I don't know, messy in my view. What I often find is that I do it this way during while I'm testing out, while I'm getting it working. Because what it means is if my first two commands here worked and then my third one, let's say I'd misspelt echo and that failed, next time I built that image, it wouldn't have to go back and redo the first one. It could just pick it up from the last successful run command and keep going. Yeah, so it can be really useful in development. But then once you know that your commands work, often it's sort of nicer and easier to chain them together like this, where I put them all basically in one run command, like that. Yeah, so that won't create any interim images for this. Yeah, it'll grab the base image and then create a new image based off that, which has the results of running my change directory, then my make dir, then my echo piped into a file. Okay, makes sense? So, I mean, this is super simple, but if we save this Docker file, and if I come back out here and have a look, if I have a look in my example directory, there's my Docker file. Okay, so let's go into that directory. Now I want to build an image based off that Docker file. So if I say Docker image build and give it, oh, better spell Docker right. Docker image build. The name of my Docker file. Now, if I've called it Docker file, I don't actually need to specify the name. I just need to specify the directory where to find it. Yep, and it's in the current directory, so I can just do that. If it was in some other directory, I'd need to give the path to that directory. Yep, and if I hadn't called it Docker file, if I called it something else, I'd need to say / whatever I'd called this file. Yeah. So I give it the name of the Docker file, and then I want to specify what this image should be called. Just like when they created the Ubuntu image, they had it called Ubuntu. Yeah, I want to give this a name. Yeah, so I'm going to call this my what will I call this? So I'll call it -t for tagging it. So I'll call it -t basic example. Yeah, that'll do. It's not the best name ever, but whatever. So let's do this and see what happens. So we can see step 1 of 2 here. It went off. It ran the from command. Yeah, and it found my Ubuntu 16.04 image locally because we used it before. Awesome. It then went to step 2 of 2, where it created an image based off that one, but that contained the results of executing these commands. Yeah, and you can see it's then created that in a container called that horrible ID. Yeah, but then at the end it's tagged it with the name that I gave it, basic example : latest. Yeah, and when you do -t wherever I did it here, that can be a list of tags. So I could have, as we saw with the Ubuntu one, I could have given it a bunch of names. So now if I say Docker image list, we should see that we've got 3 images locally. One called Ubuntu 16.04, one called Ubuntu latest, and one called basic example latest. And that image ID that we've got here should be the same image ID that we have here. Yeah. So now, instead of doing my earlier command of Docker container run Ubuntu 16.04, what I'm going to do is say I want to run a Docker container. I want an interactive. I want to interact with it, but I'm going to run basic example. Yeah. And we're into our container. Yeah. Let's have a look over here. What have we got running? We can see we've got a container called Romantic Boyd. Fantastic name. It's been going for 7 odd seconds, but the image that it's based off is now this basic example image, the one that we created using our Docker file. Yeah. And so if we have a look, what's the present working directory? Let me cd into my home directory. There's an error in my make file, in my Docker file. You can see I did a make dir to create my folder. I didn't change to that folder. Yeah, Very good. But anyway, we'll fix that. Okay. But anyway, for now, let's just check. It's created me a subdirectory called test. It's done exactly what I asked. I just asked it to do the wrong thing. And let's have a look at the contents of the foo file. Awesome. And now if I exit that and go back in, that should be persistent because we've actually baked that into our image, into our container image. Yeah. So even though we start up multiple copies of that in different places on different machines, that subdirectory and that foo file that we created is there. Now let's just fix the mistake that I made. What I should have done, or what I can do, is in between these two steps, is to change into that test subdirectory that I've created and then just append the lines together. Yeah. So now if we save this and build our image, our basic example image again, okay, it's run our statement again, created a new ID. If I then run up an instance of basic example, now hopefully if we change to our thing, yes, we should have our test subdirectory, and then if I go into that subdirectory, we should have our foo file with the correct contents in it. Cool. And again, it's persistent, because it's baked into the image. Awesome. Now that's fine if you want those files to be unchangeable and baked into your image, because let's have a look. Okay, let's go back into our image. Okay, go into test. Let's now, can we remove foo? Yep, I've deleted the foo file. Okay, let's exit, go back in, run it. I shouldn't say go back in because it's not the same container that's currently running. It's a new instance of that container, and you can see that it gives it a new ID. Yeah. If we foo's back again, because my file system changes are not persistent. Every time I run an instance of this image, I get the same starting point. We'll see in a little while what you can do if you don't want that. If you actually want to have file system changes that persist between containers. Just to sort of drive this home, let's create another Docker file example. So what directory are we in here? Let me go back out and let me make example 2. Okay, let's where's example 2? Here's my Docker file. This one I'm going to say from, but it's not from Ubuntu. I'm going to say that it's from basic example. So I'm going to create a new container image. Based off the container image I created a second ago. So it's going to be based off the result of this one. And so in this one, what I'm going to do is run what did we call the directory? Let's create cd test. And we're going to make another subdirectory called test2. We're going to echo some more contents. Into a bar file. Okay, so it's based off this one, so it should inherit the test directory and the foo file. And let's be tricky while we're in here. We're going to change into here, and in this one I want to remove the foo file, and then instead create a subdirectory called test2, and inside that have a file called bar. Yeah. Now, if I haven't missed anything there, I should be able to come out here. What directory am I in? Yeah, I'm in the right place. So let's create a new image based off this Docker file. But I'm not going to call it basic example. I'll call it less basic example. Okay. And what can we see? We can see step 1, it ran the from command and pulled in my basic example image, and then it ran these commands and gave me back this a container with this ID. Yeah, and then I named it less basic example. Yeah, so if I now run an instance of that image, okay, let's go into the home directory. Let's have a look. Yeah, there's my test directory. Should be no foo file. Excellent. And I made the same mistake again. I created the subdirectory. I didn't change into it before I created the bar file, but whatever. I won't go back and fix that one. But then let's have a look at the bar file. Yeah, it says hello again. So an image can make changes to its parent image. Yeah. But then any changes that you make when in a container based off that image are not persistent. Does that make sense? So in the earlier example, I started a container based off basic example, and I deleted the foo file. When I exited out of that container and started a new instance, the foo file was back. Yeah. But this time, in my Docker file, I created a new image from that basic example image, and I removed the foo file here. And then when I create an instance of this image as a container, then I don't see the foo file. Yeah, because there's this layered file system where we kind of, for want of a better word, inherit the changes. Yeah. Obviously, if I go back in and run up an instance, I'm still in the container. Yeah. If I run up an instance of the basic example one, it's still there. And the foo file is still in the test directory. Yeah. But in the less basic example image, that's been overwritten, if you like. Yeah. Okay. So if you want to have file system changes and applications installed or whatever that are persistent in your image, then that's where you would start creating a Docker file. Okay, we'll kind of come back in a second and look at other ways of doing this. Yeah.